as we start the preview, I'll be mentioning enough about the notes as we go, so I'm going to move that out of the way for a minute here. So we are starting with the new stuff, solving the radical equations. And so as we get here on that, the biggest thing I am going to need to help me out here, so I'm going to fold this really quick, are the directions at the top. And there they are. Okay, isolate the radical. Make sure the radical's by itself. So for this first problem, step one is done. I don't have to do any opposites. It's alone already. Step two, square both sides of the equation. Okay, so squared just cancels out square root. The right side, 5 squared is just 5 times 5. But if you're like, not sure if I'm going to remember that or not, remember, here is your squared button. I know it says x squared, but it's just going to put a squared on there for me. And I can get my answer that way. And now we're into two-step equation mode, which hopefully at this point of the year, we can do our opposites and get ourselves set. So that hopefully should not be too complex. Okay. Now, are they always going to be quite that straightforward? No. And if they're not, we have a plan for this. So again, when it talks about using inverse operations in our notes, add and subtract, multiply and divide, again, we'd have them there. So my first job is to get that radical alone. How am I going to get rid of the 3? What's my opposite of multiplying by 3? Say it is much harder for these to go smoothly if you're just kind of a consumer. Because when we do that, now we're in the exact same situation we were here. Again, squared and square root don't like each other. They wipe each other out. And my key here again is this does not have a radical. There's my squared. Ooh, 100. We're going to get some big number this time. So you're like, wait. So I might have to do opposite stuff before the squared and after? Yes, depending on the problem, you might. And we get ourselves set up there. And so even though it's repetitive in some ways, this is why I always talk about using colors and showing steps, because that way, when you look at something like this, you're like, oh, that's -6. I know how to get rid of that. See here. So I got to get rid of my square root next with my squared. Okay, that goes away. Again, 8 squared is 64. And do my one opposite. So a lot of first semester equation solving once we get into here. So equations, that basically what you see is what you get. Now when we get to the functions, when we get to the square root graphs, now there's a little more going on here. So the first thing it asks me is to list the transformations of the function. And the number of blanks are going to tell me how many of them there are. So maybe I just notice at the start. Okay, so I see -3 inside. Okay, so that's right 3. That's this one. And then I see there's a number on the outside, but it's a minus. So I'm like, okay, that's down 2. Well, Hardy, there's still a blank left, because there's still a number here on the outside. So if I go a little further down on here, if there's a number outside and it's bigger than 1, that is, we're going to have a stretch of 2. So the blanks will give me a little bit of a clue here. Okay, but again, if I've taken this part down, it's going to be real easy for me to find something that's similar and then just use the same words for that as I go. So, the graphing part. Okay, so now what am I going to do? This is where we go to the calculator. And this again is where you're going to want to be sure that you've got your note stuff updated, whether it's getting it off a classroom or getting it off that front board, to know how to get this in. So you're like, well, wait a minute, what's this craziness? Anything of x is just a fancy way of saying y equals. We're still going to y equals. And if there's stuff in there when we get there, we're still just going to hit clear, and that's going to make it all go away, which is nice. And we start typing. When we get to the radical, see it over there on the board at the very top, second, and there's that x squared button again, but there's my radical, my square root. Here's my x. -3, not -3, but -3, and the -2 is outside. So the calculator tells us when you're done inside, hit the right arrow, there it goes, -2. So as long as this basically looks the same, I can look at the graph if I want to first. And I notice I went right, I went down, and I stretched, because again, this is all based on starting from the middle, starting from the origin. So once I want to get the chart, because that's going to hook me up, second in graph, that's also over there to get my table. There's all my error messages. We're on the right track here. And I'm going to start jotting down pairs. Now, what happens if you're doing pairs? I'm going to write the 12-4, but what happens if I only get 3? That's okay. 3, 4, either of those would be fine. But those are the 4 points now. Here's my x and y axis. These are coordinate points. Here's where x equals 3. Here's where y equals -2. Here's where x equals 4. And y equals 0. 7, 2. And again, 12, 4, I mean, I can kind of eyeball it if I want to give it a try here. Got to have the arrow on the right side. We don't put one here because, as the calculator tells us with the error messages, once we get past this 3, everything else doesn't work. So we don't put it there. And then we hopefully remind ourselves of the easiest domain and range ever. The first x value in your chart, the first one that's after the error, is the start of your domain. It starts here at 3, goes off forever to the right. My range. First y value after the error. Starts down here at -2 and goes up forever after that. And that's it. So what I'm hoping you're noticing is calculator does the work, calculator does the work, calculator does the work, notes do the work. As long as you have the tools, you've got everything you need for that to be a very successful section for you. And that's a lot of parts, so that's going to be a lot of points. So not too shabby. Little review. Again, our radicals, we got our list of numbers here. You're like, ooh, you're not giving me the list this time, are you? Nope. You've got notes. You've got a way to have the list. And so, as we've seen before, the goal is, man, 72 is a big one to start with. We start with those numbers in the chart, or my box, that are less than 72, and we're going to start dividing them in until we run into that first one that goes in nice. 36 and 2. 36 is perfect. It breaks down to 6. 6 square root of 2. Hardy, does it matter which one I get out of there? Yes. The only ones that can get out are these numbers. If it's not in this box, it does not get out of radical jail, and that's just how it works. So for the next one, I'm going to do the same thing. I'm going to ignore the 8 for the moment. Cover up those numbers that are greater than 28 and start dividing them in until, hopefully, maybe I find one that goes. 4 and 7. Only the one in the box gets to break out. So what's this going to look like? So here, I've got 2 times the square root of 7, but that 8's still lurking out here. So I multiply those two together, and that gets me to my final answer because they're both not under the radical. So I can do that. And again, if you've written down your examples, you have examples of when there's a number outside or just the numbers in here too. So we got lots of good tools. Now this one, I'm not going to say I'm trying to fool you with it, but I really need to be careful because I look, wait a minute, 16 is actually in the list. So this one, the square root of 16 is 4. I don't need to break this into pieces. Because even if I did, I'd have 16 and 1, and that'd break down anyway. So that one just, I multiply them together and I'm done. So if you get one that's just a whole number like that, you can go straight to it. That would be okay. You might not tomorrow. We'll see. But again, proven point, if you've got your notes situated, you got a lot of good stuff that makes this easier. Not as easy as if you've got them done yourself, but still could be easier. All right, let's see here. Holy cow, I got to get down. There we go. All right, adding radicals. Do I have help for this? I have help for this. Bring this down a little. So we need to try and simplify things. Now, if they don't simplify, because I'm looking at my list, I'm like, there's nothing that goes into 2. Leave it alone. But if I need to, I bust my list back out, And I'm going to start dividing these numbers into 98 until I find something, or maybe I'll find something. Maybe I won't. I don't know. But I'm literally just running down this list. And I find one, 49 and 2. So, $49 gets out, 2 does not. And now I can go ahead just like we did in the last section. Those two numbers that aren't under the radical, we can multiply them together. And since these are the same, I can add the numbers on the outside, the coefficients. If these weren't the same, I'd just leave it alone. I'd circle it and I'd be done. So again, there are some options. But again, real similar to what we saw in that last one. And then, even though it's not exact, find a simplified expression for the perimeter. Oh, I'm just adding up the sides, things that are alike. Hardy. I could do my perimeter just with this, but I also know with a rectangle that I could work my way around here, and now I'm just looking for like terms. So these are alike, and again, perimeter is just add. So 2 and 2 would be 4 square root of 5. These two have the same radical. 9 plus 9 is 18. And just like we saw over here, these aren't the same. So I can't go any further. They don't break down. I cannot add the 18 and the 4 unless the radicals are the same. So I'm just kind of playing that through. You're like, whew, we're getting there. We're getting there. Multiplying radicals. Okay, let's see here. Multiplying radicals. From my notes. Multiply the outside numbers together. All right. Multiply the inside numbers together. If possible, reduce the radical. One way to find out, start dividing my numbers in here again. So 49, no. 36, no. 25, 20, there it is. $25 is perfect. Gets out of radical jail. So now you're like, okay, so what's all going on here? So my 50 became 5 times the square root of 2. 5 got out, the 2 did not. But what about the negative 24? I can still multiply those together. And get to my solution. So as we're doing these, you're like, ooh, what's going on there? Okay, I got an example for that too. So in this case, my squared goes to the 8 and goes to the square root of 3 to each one. And as I notice over on my example, okay, 8 squared, I just type in and I get that answer. But here, the squared and the square root cancel. So it just stays what it's under there. I'm not squaring the 3. And then we just multiplied those two together. So it really does just become a game of following my examples, which if I've been doing practice, it's going to make them a little easier. So one more in the current unit, and I got an example again here because here's the area. Area is length times width, so I'm going to be multiplying these together. So it's going to be kind of similar to what I did over here in number 1. Multiply the numbers outside. Multiply the numbers inside. Now, when I did it over here, my radical broke down. Let's try it here. So with 10, I got 9, no. And 4 doesn't work either. So if I get to the end of my list and nothing's gone in even, I'm just done. Could that happen tomorrow? Maybe. Maybe. I just got to watch for it. And then we have our trip to yesteryear, and you've survived. So here, John started a food truck selling the best hot dogs in Chicago. Okay, it's a cost versus revenue problem. So here's what I would say if you didn't have your Unit 6 notes still. So it's a startup cost of $7,000. So I have costs over here, revenue or money I'm bringing in over here. Startup cost. Okay, so that's $7,000. Okay. It cost 75 cents for each. Oh, do we remember this word? Each is a variable, is X. So 75 cents for each hot dog. He's making money, the hot dogs for, $5 each. No kidding. Well, in today's society, that might not be too out of line. I don't know. But for every hot dog, he's getting $5. That's why I put the X here. So you're going to have an X on each side of this, and now I'm just going to solve the equation. To me, since there's only X's on the revenue side, I want all my X's over there. I'm going to bust out the calculator for this because this is out of my brain's pay grade here. 5 minus 0.75, 4.25. And then just divide. You're like, okay, now, we have to use a little common sense here. Can I sell 0.05 of a hot dog? Probably not. So, when in doubt with these, you're going to have to round to the nearest whole. And since we're at 0.05, we probably wouldn't round up. We'd round down slightly. We just don't want the partial hot dogs. I don't know who's going to want that. Just the end that you cut off. So cost and revenue. All right, last one. One night at the McDonald's, Mrs. Hart's family bought 4 value meals and 2 apple pies for $29.78. That might be cheap these days. Next time they went 3 value meals and 5 apple pies for $25.80. Set up a system of equations. Set up only. Set up only. So I am going to make value meals be V. So I got 4V. And 2 apple pies, I'm going to make my apple pies A. Is going to cost me $29.78. You could use X and Y. I don't care what variables you use. But each sentence here with numbers is going to give me a different equation. Next time they went, 3 value meals and 5 apple pies for $25.80. I don't have to solve. I'm done. I'm finished. More ways than one. So, you know how I work. This is basically a setup of exactly what you're going to see on quiz. So a couple of points of reminder. If you need some more equation practice, there is a puzzle on page 11 that if you do and put that in with your practice packet, you would get extra credit. Also a reminder from yesterday, if you work on the one that we started on page 3 yesterday, get that in your packet, that would also be extra credit. Plus, here on Classroom, those are the 4 assignments in the packet that you would need to have done in your practice. It also makes you do better on the quiz too, probably. The notes are now here and complete, if you need them, including your button presses for the calculator. And I will post the video here as well a little later if you need.